Hi everyone, welcome to minuteElements. In this video, I will be talking about circular system of angle measurement, which is more commonly known as radian measure of an angle. Now, since in school we are taught angle measurement in unit degree, we are more comfortable when angles are described in degree. So let's start by stating some known facts about angle measurement in degree. Consider a circle with radius r. Now we know that one revolution around this circle corresponds to an angle of 360 degrees. Similarly, a quarter revolution around this circle corresponds to an angle of 90 degrees, which is also known as right angle. And a half revolution around this circle is equal to 180 degrees, which is nothing but a straight angle. Now, since we know these facts about angle measurement in degree, we are more comfortable when an information is given about an angle in terms of degree. Consider an example. If we have said that angle ABC is equal to 40 degrees, to most of the people this creates a clear picture of an acute angle which is almost halfway to 90 degrees. And if we are asked to draw this angle, we can create fairly accurate representation of this angle without the help of any mathematical tool. Now imagine if somebody asks us to draw an angle which measures 2.5 radians. In the beginning, it does not give us any hint how this angle looks like. Is it an acute angle or is it an obtuse angle? Now, the purpose of this video is to make the idea of angle measurement in radian more intuitive and get away with the confusion which we have. So let's get started. So basically in this video, we'll be talking about three fundamental things. First, we will define the radian measure of an angle, which is also known as circular system of angle measurement. Then we will show that definition of 1 radian is independent of the radius of the circle considered. And at the end, we will establish relationship between radian measure and degree measure of an angle. So as whenever an angle is given in degree, we can convert it to radian, or if an angle is given in radian, we can convert it to degree. We'll take some examples to make our understanding stronger. So let's start by developing the idea of 1 radian. To define the idea of 1 radian, let's consider a circle with radius 1 unit. Now imagine a point moving along the circumference of this circle, and let's say that the length of circular path covered by this point can be represented along a straight horizontal line. And to do that, let's unwrap the circumference of the circle and represent it along a straight horizontal line. Now imagine this point moves from position A to a new position B, such that length of arc AB is equal to radius of the circle, which is 1 unit in this case. Then the measure of angle AOB subtended by arc AB at center is called 1 radian, and this can also be represented along the straight horizontal line. Now imagine if we try to reconstruct the circumference of the circle in terms of length of arc AB, then we can see that we will need more than 6 such arcs to completely cover the circumference of the circle. Now 1 arc corresponds to 1 radian, and therefore we can say that to construct the circumference of the circle, we will need more than 6 radian. To be precise, 6.28 radians, which is equal to 2 pi radians. Now the same idea can also be developed using the formula of circumference of the circle, which is given by 2 pi r. Now in this case, r being 1 unit, the circumference becomes equal to 2 pi, which is same as what we established earlier. In other words, we can say that 1 revolution around the circle also corresponds to 2 pi radians. Earlier we had seen that in terms of degree, 1 revolution corresponds to 360 degrees. And therefore we can say that 360 degrees is equal to 2 pi radian. Now let's try to understand the definition of 1 radian in a more general way. So let's consider a circle with radius r units, and let's imagine a point moving along the circumference of this circle from position A to a new position B, such that length of arc AB is equal to radius of the circle, which is r units in this case. Then the measure of angle AOB subtended by the arc AB at the center is called 1 radian. That is, angle AOB is equal to 1 radian. Now let's try to understand how this definition of radian is independent of radius of the circle. So let's redraw the same circle over here. Now in this case, length of AC, that is segment AC, represents a diameter of the circle, and therefore angle AOC is a straight angle which measures 180 degrees. Now to show that the definition of radian is independent of the circle radius, let's try to use a concept which says that the angle subtended by an arc at the center is proportional to length of arc itself. Now using this idea, if we try to define the ratio of angle AOB over angle AOC, we can say that this will be equal to length of arc AB over length of arc ABC. Now length of arc AB is equal to R, and length of arc ABC equals to half of circumference of the circle, and therefore this ratio becomes 1 over pi. Now if we rearrange the terms, we can say that 1 radian, which is equal to angle AOB, is equal to 1 upon pi times angle AOC. Now this expression does not contain any terms of R, and therefore we can say that the definition of radian is independent of the radius of the circle. Now if in this expression, if we rearrange the terms once again, we can say that pi radians is equal to angle AOC, which is also equal to 180 degrees. Now this establishes a relationship between radian and degree, which says that pi radians is equal to 180 degrees. Now let's use this relationship between radian and degree to convert angles from degree to radian or radian to degree. So we know that pi radians is equal to 180 degrees. So we can write down 1 degree is equal to pi upon 180 radians. Now using this expression, we can convert angles from degree to radian. Now as well as we can convert angles from radian to degree. So we can say that 1 radian is equal to 180 upon pi degrees. Now let's try to use this relationship and convert some standard angles from degree to radians. So let's consider an angle of 30 degrees. Now if I multiply this with the ratio pi upon 180, I get pi by 6 radians, and therefore I can say that 30 degrees is equal to pi by 6 radians. Similarly, if I have an angle of 60 degrees, I multiply this with the ratio pi upon 180 and I get pi by 3 radians, and therefore I can say that angle 60 degrees is corresponding to pi by 3 radians. Now if I have any unknown angle in degree, I can convert this into radian by multiplying with the ratio pi upon 180. Similarly, if you have an angle in radian, you can convert it into degree by multiplying with the inverse ratio, which is nothing but 180 upon pi. Now here I have shown some standard angles converted from degree to radian. Now you can use the above expression and recheck the values mentioned over here as an exercise. Now using this idea, we can say that in a circle, a quarter circle corresponds to 90 degrees, which is equal to pi by 2 radians. A semicircle corresponds to an angle of 180 degrees, which is equal to pi radians, and one revolution around the circle corresponds to an angle of 360 degrees, which is equal to 2 pi radians. So that's it for this video. I hope you liked the video and enjoyed this. See you in the next one.